Okay, today we're going to cover section 5.1, and with this section I'm going to want you to have your pink sheet available when you're going through this along with your notes, because we have quite a few formulas that we're going to cover. In this section we are starting the statistics side of this class. We're finally getting through the probability, and we're going to statistics. And within this, what we're going to do is distinguish different random variables, discrete to continuous. What's the difference between them? Graphing probability distributions, which is similar to what we have already done before, and then we're going to compute the population mean and standard deviation for just one more group of data. So what are statistical experiments? Simply any process by which we gain a measurement or obtain a measurement. So it can be one of two things happening. You're either going to count or you're going to measure. So a few examples: counting the number of M&Ms, measuring a braking distance, measuring a wingspan, counting the number of books. So there's two main differences with variables. Now what are those two differences? Okay, quantitative variable x. Okay, it's a random variable if its value is determined by an outcome of a random experiment. Okay, and then we can, these are the two different ideas. They can be discrete or continuous, and that's what we need to try to determine. What are the differences between discrete and continuous? And it goes back to the counting and or measuring. So a discrete, a random variable that can only take on a countable or finite number. So you actually literally need to be able to count the number. Okay, that's what a discrete random variable is. So the number of words on a page, you can literally count those, or Microsoft Word can count those. The runs scored in a baseball game, you can count it. The number of wells you drill until you hit oil, you can count that. So that's the idea of when you're reading a situation, can you actually physically count what's going on? If you can, then it is discrete. If it's continuous, okay, continuous random variables, these are variables that take on a countless value or an interval. You can't necessarily pinpoint an exact value to it. So the volume of air in a balloon, you can't count that. You have to measure it, and it could be anything from 0 to, depends on how big the balloon is. The height of children in a kindergarten class, you have to physically measure that. You can't count that. You physically have to measure. And then it goes into, well, how specific of a measurement do you want? Inches, centimeters, millimeters. There's so many different levels, and actually you kind of grow all the time or you shrink. So it's not an exact science. So that's why it's continuous. The weight of cargo on a tractor or trailer, the weight needs to physically be measured. You can't count it. You have to measure it. So that can also change depending upon to how specific, to the ounce or whatever. Okay, it can change. Temperature of patients in a doctor's office, you physically have to measure the temperature. So that's the difference. Okay, with discrete you count, and with continuous you measure, physically measure it. Alright, so what's going to happen on actually these, the first two homework problems give you a slew of different ones, and you're going to have that on a quiz as well. So you might want to work through number 1 and 2 on your homework and make sure you kind of manage the difference, or we'll talk about it in class a little bit more in depth. Alright, probability distributions. It's the assignment of probabilities to each specific value or range of values. Okay, so that's what a probability distribution is. You have, it's right in the word. Probability, you have to have the probabilities. Distribution means you give it to each part of whatever we're talking about. This discrete probability distribution, to be a discrete probability distribution, each value has an assigned probability for whatever we're talking about, and this is the most important part. The sum of all the assigned probabilities must add up to 1, i.e. you have everything in your your sample space, basically, if we go back to probability, in there, and the probabilities all equal to 1. So we can measure it, that's why it's discrete, it all adds up to 1. So just a quick example of this would be flipping a coin 4 times. Now I could go through and give you a tree diagram if you want, but I'm not going to do that, and you would end up getting like 16 of them back here. And you would have H, 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 and H. Like, you can flip heads 4 times. Well, that's only going to happen 1 time. So this is the probability distribution here. Alright, I believe we have, well, 1 time we can have no heads, 1 time we can have 4. I believe it's 4 times 1, 4 times 3, And then what do we have left? 5, 5. There's 6 times that you will get exactly 2 heads. That's the idea. But instead of putting the frequency, the number of times they happen, they put the probability in here. That's why it's discrete probability distribution. They're using probability instead of actual physical numbers. So that's the only difference. These numbers that I have circled, these probabilities, will add up to 1 because you have every possibility. Okay? And then in this example, the probability of getting 2 heads after 4 flips is about 37.5% or 0.375. And that's how they go about doing that. So that's an idea of what happens. How do they show it? This is a graph of discrete probability distribution. This is no different than what we've done before. Essentially, this is a histogram. Your midpoint of your classes are the number of times the head shows up. Okay, your bars go halfway between, plus or minus 0.5. That's all that's happening. And then they have the probability going up on the y-axis. So here's your point, or like 0.0625, 25%, 37.5%, and so on down the line. So it just looks like a histogram. It's the same idea. Discrete probability distributions can be shown via that histogram. Okay. Now, what are the features? What are we using? What's it for? Okay, so we're basically thinking about it as a relative frequency distribution or relative frequency histogram for a very, very large sample. Essentially, we're going to include all of them. Okay, so we're going to actually find the mean and standard deviation for this problem, except we're going to assume, since it's probability, we're going to actually assume population, and I'm going to show you how the calculator also thinks about this. So how do you calculate the mean? And then we're going to go back to the coin problem. How do you calculate that mean? If you look at your formula sheet, I believe it's the very first formula for chapter 5. It says mean of discrete probability distribution, and it has the mu. What does mu stand for? Yes, it stands for the mean, but it's the expectation or expected value of flipping a coin. Okay, long run average if you want to think about it that way. What's the formula? Well, this sigma comes up again. This just means the sum of this. If you take your x, and in the last problem with the coins, it'd be the 0, 1, 2, 3, 4, 5, and 6, or 0, 1, 2, 3, 4, and then times the probability of it, and if you add them all up, that's what we're going to get for the mu. Okay, and then the standard deviation formula is the one right below it. It's going to be a little bit more difficult. We're going to have the sum of, and we're going to go back to making those columns the long way. Okay, each x value minus the mean, subtract them, and then you square them, and then we multiply by a number, and we're going to see that. But basically, the Greek letters mu and sigma are used because it's population. And on the next page, I'm going to show you how to calculate the mean. So with your, sorry, the bell just rang. I'm doing this in 8th hour. Okay, with your formula for mu, so it's the sum of x times probability of x. So what you need to do is take every x value and multiply it by the probability of it. And that's what I do on this next line down here. Okay, so we have this x value, 0, times the probability of x. This x value, 1, times the probability of x. And so on down the line for every single column or class, if you want to think about it that way. And when you add all these up, 0 plus 0.25 and so on down the line, you'll end up getting the expected value of 2. So the mean or expected value when you flip 4 coins to get a head, we expect to get 2 heads when you flip 4 coins. And theoretically, that kind of should make sense. Standard deviation. Now I have done all the work for you. I have not covered anything up, partly on purpose. But notice this is the same situation. Now how does this formula work? Here's the formula that you should see on your paper. It's the sum of each x value subtracting the mean. Well, we just found the mean was 2. So every x value, 0 minus 2, 1 minus 2, 2 minus 2, 3 minus 2, 4 minus 2, that's in this column. Each x value, subtract your mean, and then we need to square that number. That's what's happening in this column right here. Negative 2 squared is 4, and 1 and 0, 1, 4, and so on. But then they say I want to multiply all of those by the probability. So 4 times the probability of x, which is 0.0625, is your 0.25. 1 times 0.25 is 0.25. 0 times anything, 0. 1 times 0.25, and so on down the line, and you will add these up. This becomes your standard deviation, or your spread. Okay? And then when you add all of them up, we end up getting 1. Now that is the long way to do it. How else could you do this? I'm going to show you via the calculator. We have done this. This is essentially grouped data. Okay? So if you put your x values in your list 1, and then your probabilities in list 2, type them all in, and then you do the first variable stats, L1, L2. Now some of you, hopefully we all know how to do this, but I'm going to go calculate first variable statistics, L1, comma, L2, and I push enter. Notice your x bar is 2. That's your expected value, your mean. Now what's interesting is we had probabilities already put in here. So notice the standard deviation for sample does not show up because your calculator already is knowing, since it's probabilities, it's the population. And your standard deviation, your sigma, is 1. Now this is x bar. It should be mu, but the calculator is going to show x bar. So that's the only thing that's different. So you can use this. You can find all of the means and standard deviations of any of these problems in your homework simply by doing the group data idea that we did in the last chapter. Alright? The last part, so that's the first part. The last part are these crazy looking formulas below. Okay, we are doing a linear function, so we're going to kind of tie lines in with formulas, and there's a few problems that we do this. Now I'm not going to lie to you, we don't do this all that often. My focus for you would be the slides before this. But I'm quickly going to go through and show you these formulas. So what formulas are we going to use? Okay, the mean of L, you'll see that there's a given, right below standard deviation, there's given L, and it looks like this right here. Okay? And then it has the mu of L equals this one, and then we have the squared one, but notice they don't have the squared one. They have this guy right here. Okay, so what we need to do is go through. I just want to show you a concrete example of what we're going to use. So they're saying let x1, some variable, okay, have a mean of 11, standard deviation of 2, and they give you this line. Alright, and what they want you to do is calculate your mean. So I have an example right here. All you do, okay, all it says is to find the mean. You do A plus B times mu. A mean of L equals A plus B times your mu. Okay, and what this is your line L equals A plus BX. So the B value is essentially your slope, is what they're saying. So you want to dump that in. Okay. Sorry, I should shut my email. Your A value, okay, is like your y-intercept, if you want to think about it that way. And then to calculate your mean, you have your A value, your B value, and your mu. Well, the mu is 11. So all I did is I take my line and I plug my mean in. And you just calculate it. 12 times 11 minus 7 is 125. So the mean of this is 125. It's just a matter of finding your formula and dumping it in. Okay, your sigma squared. Now I don't have that on here, but it's on the previous page. Okay, but all you do to find the variance squared essentially is take your 12 value, or your b squared, okay, and you times it by 2, which is your standard deviation squared, and you get 576. Then you could do one of two things. You could either take the square root to get 24 for the standard deviation like anything else, or use the formula that we had on the previous page, which was the absolute value of b times your standard deviation. Okay, your sample standard deviation, or the variable. So then it's just Absolute value of 12 times 2 is 24. Either way, you would end up getting the same standard deviation. So that's the idea of that problem. And then they also have two variables. So this would be the next one down. So they say given W, and I tried to underline these already to kind of help you out. Okay, if they give you the W, how to find mu would be A times the first mean plus the B value times the second mean. Okay, and your A value is going to come right from the problem, the A and the B value. Then your variance, okay, we have these, and so on down the line. Just a quick example, so you can try do it. I believe there's only one problem in the homework. The first variable, x1, has a mean of 11, a standard deviation of 2. So that's the first example. The other variable, whatever it happens to be, has a mean of 3, standard deviation of 1. How do you calculate the mu? All it says on your formula is A times x1. Well, what's your A? It comes from your original line. So here's your line. This is your A value. Here's your B value. A value is 7 times mu1. Okay, that's 11. The negative 5 comes from your B value here times the mu2, which is 3. And you just do the math. It's just plugging into formulas. It's just a matter of trying to work at it and figure it out. What's the variance? Well, variance squared, okay, they take the A squared times the standard deviation squared. So your A squared is 7. Standard deviation of the first one is 2 from up top right here. The B value is negative 5. The standard deviation of B is 1. And you just add it up and get to 21. And then just like anything before, how do you go from variance to standard deviation? Take the square root. So it's just a matter of figuring out which formula or which equation. Is it one variable or are there two? And if you can tell there's two, then we use the W formulas from your sheet. Or if it's just one specific variable, then we use the L formulas from your sheet. And that's kind of the idea that we're looking at with those. So your assignment, we're going to go 1 through 3, 5 through 9, 11 odd, and 15 in class tomorrow. Hope you guys all have a wonderful day.